Alright, time for another draftphysics.com, debatephysics.com also, where there's lots of very short 5-minute videos making specific physics arguments about specific experiments, outcomes, what we know, what we think, that kind of stuff. What's theoretically possible, impossible, different statements made that I would like a response to in some sort of, reasonable manner where you're actually going to respond to the statements about the physical universe and how it works. But anyway, haven't been able to solicit that. And it's unfortunate that we don't have some place that's a neutral place, a moderated place to have a conversation where we can be assured the subject stays on the physics and not all this other crap, frankly. Where the other crap is crappier places. But anyway, some sort of neutral ground. And yeah, it's an argument. And yeah, it is sort of important. And yeah, it does have to do with really important features of our civilization. How it detects the truth. I mean, it, in my opinion, would be silly of an atheist not to be really pissed off that a bunch of religious kooks are deciding the course of the history of its civilization. That should piss somebody off. And I'm likewise quite irritated because I believe science has made some grotesque and almost gratuitous errors in jumping to conclusions. I mean, dark matter, dark energy, entanglement, superposition, all this stuff on these tiny little fragments of evidence. They draw these hard, draconian, rigid conclusions based on completely incomplete, observational data. And that's the real point, too, is that they don't do any of these experiments. We can't go to conventional or established physics and say, what happens when? They don't have an answer. They don't have the experiment. Simple things, Newton's cradles, banging things into brick walls, all this stuff, they don't have anything to add. They can't contribute to the conversation with anything called evidence, which is, almost laughable that you go to the scientist and say, where's your evidence? And they say, well, read my Bible. It's in my textbook. It's kind of, So anyway, since physicist Michael likes predictions, maybe somebody can get him to play along, and we'll counter two predictions about what happens. So I'll detail a simple experiment. It hasn't been done, as far as I know. No one's done it, and it's really, it's really very, very simple. But yes, it would be best to have, technology to detect velocities and all that stuff. So somebody with the right equipment should be the one doing it. All right, but so the simple challenge is, what's your prediction for this circumstance? All right. I'm going to talk about a lot of stuff in this video, so it's basically, I'm going to talk about it, but I'm not going to be able to write about it with this marker. Pause. Alright, should be back. We'll try this one instead. Alright, so simple experiment. Just a scale or a spring. Just have a spring, it doesn't really matter. You put a weight on it and get a detectable change in the spring, so you can detect the fact that it's been compressed by the weight. Okay, it's a significant change in its deflection, or whatever you want to call it. Its displacement, it is displaced sufficiently to register the displacement. All right, it weighs whatever, 10 pounds, whatever, who cares? My idea is, my suggestion is, we know that's a compression, so you just mark that level or you freeze it at that position, but the idea is you're just going to put the scale horizontal now. And you're going to have the same spring compression, with the same energy in it, the same 10 pounds of energy. And the simple truth is what's it going to do if you put 10 pounds on here? And what's it going to do if you put 5 pounds on there? Okay, what's going to happen to that weight? And my simple argument is it's going to do exactly what gravity did when it pushed the weight in. This is the spring compression for the weight of 10 pounds. And it will push it at 1 mile per hour. 1 mile per hour. And now if I put half the weight there, it's really got to be 2 miles per hour. And if I compressed it with twice the weight, so let's say I compressed it, I put a 10 pound on and then I put another 10 pound on, so I only do 2 units of work, obviously. I mean, the people, Physics Michael is kind of grouping with, or at least not criticizing in any way, they say that that means it has 4 times the energy. That's their argument. That twice the weight is 4 times the energy. So now there's 4 times the energy in the spring. Now, I would argue that obviously if I have that double compression, that 20 pounds, the 10 pounds is only leaving at 2 miles per hour. Okay, it's not going to be going 4 miles per hour. And the 5 pound will be going 4 miles per hour because, yes, it's 5 pounds and 5 to 20 is 1 to 4. And so it'll go 4 times faster. So what's his prediction? So my prediction is 10 pounds on a 10 pound weight, 1 mile an hour. 10 pounds on 20 pounds of force, 2 miles an hour. 5 pounds on 10 pounds of force, 2 miles an hour. 5 pounds on 20 pounds, 4 miles an hour. So just curious what his textbook predictions are for this simple experiment. I mean, you can't get much simpler realistically. Now, obviously I would do this with a pendulum or something, so friction, all that kind of crap, or a very slick glass surface or something, but whatever. It does need a timing gate kind of thing or something like that. So the fact that we don't have the answers already, that to me is a test of your credibility, that you can't utter the words that, that is a shame. It's a shame science hasn't treated any of these elemental factual experiments, these foundational experiments, to be important enough to actually do and to confirm. Instead, they just leave it ambiguous, as if, they just tell you what it is. They don't show you what it is. And obviously, I think what the story they're telling can be critiqued as not very connected to reality, and such. As I guess I'll point out as I go through my list of crap to go through in this video. So there, I've kept it as polite as I can, and so maybe somebody can suggest to Physics Michael that this is a reasonable thought experiment for him to engage in and predict what he thinks the outcome is going to be. And then somebody can do the experiment. Yeah. Alright, so I did find some video editing software that actually works fairly good. So I might be able to do some video editing more detailed in the future and such, so that'll be good. I have to learn how to use it, of course, which is always very time consuming and such. And so we'll just play some of this. So I got the 2 videos next to each other so you can get a better, only for the beginning does it match, but yes, it does give you a pretty good view of the 2 of them side by side. So let's see if I can do this frame by frame. Oh, I can't do it in this software. I have to load it into a different program. But anyway, you do see some defects in terms of the way the lever pushes. It gets very angular. So I'm thinking I need to create some sort of round surface on the lever so it pushes evenly. That would be more ideal. Now I don't have a stop on the lever. Now I can make a stop fairly easily to stop the lever from going any further. But part of me says, well, really the real test is to allow it to go all the way. So, so they don't leave exactly at the same time. So that way I'd like to just compare the speed of the bar, because theoretically the bar is going to be moved at the same speed for both objects. So that one leaves first, and then it's just off to the races. I mean, it's so fast, which, does make it a little bit imperfect. So again, this one did leave first, and it just clearly the arc is this, the time of the arc is going to be the same for both. So this part is a little bit interesting. So if you let it go, if you let it play out, pause. Just one of the little harassers. I think he dropped his phone. Anyway, it's just so pathetic that people have to resort to this horse shit. But anyway, continuing. So where was I? Yeah, so watch them coming back is the interesting part. So this one, the bottom one obviously went a shorter distance, the longer one went a longer distance, and now it's going to catch up, and they basically come back to the starting line at the same time, which is, fairly interesting, So this one's obviously twice the distance, it seems obvious, and it's obviously doing it in half the time. So it has to be going twice as fast as an average velocity. It has to be going twice as fast if it went twice the distance and got back to the same location in the same time. So that's sort of telling that it's no 1.4 crap. But anyway, just throwing it in there. It needs to be a better experiment, but again, they need better experiments. They need real evidence. And so this argument should be about these experiments being done with precision instruments and done well. It shouldn't be about whose crappy experiment is more convincing. So it is just so disappointing that real physics doesn't take any of this seriously. It's not a subject from their perspective. Alright, so a subject that remains unresolved. They have made arguments, I'm making my counter arguments clearly, is this idea that twice the weight can, in some possible way, equal 4 times the energy. So it's almost back to the gravitational idea that in gravity you fall twice the distance, and 4 times the distance, but you only gain twice the velocity, and that only produces twice the weight on a scale. And so you're stuck with this idea that it's 4 times the distance, so it must be 4 times the energy by their theory. Now, I don't know why they persist in arguing that, just because it's only twice the time in the gravity, and it seems quite unimpeachably true that gravity is about how much time you're being affected by it, how long you're free falling in it. But anyway, they persist in making this argument. Now, unfortunately, see, we don't have a simple answer from physicist Michael. He hasn't just stated. He won't answer the questions kind of directly, so we're still left kind of not knowing what his opinion is. Does he think if a spring is compressed twice as much, it has 4 times the energy in it? Whatever 4 times would be. But twice the compression means it can do 4 times the work. So it can do a certain amount of work with 1 compression, and twice the compression, now it can do 4 times the work. Does he believe that, or does he dispute the other players in this conversation and reject that idea? So again, there's experiments you can do to get to this truth, but they just don't get done. So we're left with this, by their definition, unresolved. By mine, I'm just saying show me, because I can't see how it's possible. You can produce twice the weight with doing half, only 2 units of work. So how could it possibly be 4 units of energy if you only did 2 units of work to create the compression? It seems a logical sticking point that I haven't heard a counter-logical argument explaining why that's not logical. Alright, so so the other one is Brozosian argument, that it takes more energy to move a half mass 2x the speed. So if you have a spring compression and you can push a 1 mass with it, he claims you can't move the half mass at twice the speed. Now obviously the lever thing I just showed you, the catapult, says you can. And I'd say everything about all of the historical physics, where they talk about catapults in the past and all that stuff, it really was the law of the lever is what everybody thought, so they haven't really countered that. I haven't seen anybody say that's not true, that twice the distance gets you, twice the velocity, but it can't give you twice the velocity of the same mass object. You have to have half the mass, and then you can get twice the velocity. And that's sort of the rule. So the further out on the lever you go with a lighter object, the more velocity you can give it. And it's completely proportional to the distance from the fulcrum. So should there really be a dispute about this? But apparently there has to be, because people do experiments with springs, trying to compress them or trying to take the energy out of them, and they get these erroneous results. So, for example, it's on my list, so it's really out of order, but it's sort of related. So physicist Michael has done an experiment where he gets more energy out of a spring, more momentum, sorry. And it seems kind of open-ended, all right, in the sense that it's almost like you could go to some infinity in both directions. So the idea is you have the same spring compression, and then you do these two separate experiments with the same spring compression. The same force is affecting the two experiments. So the same force is here, and you get 400 momentums here and 200 here total energy going away from the explosion. So the total objects moving, these numbers happen. So the obvious statement is, does that mean that the lighter I go, the less energy I can get out of a spring, and the heavier I go, the more energy? Now that would be consistent with what Brozo says is the truth, in the sense that heavy objects seem easy to give momentum to, and somehow light objects are hard to give momentum to. But I'm saying it doesn't make much sense, does it? No. So how high can this number go? I mean, how much weight can I put on here? Can I go to 20 pounds? And end up with let's see, what would that would it be? 2,000? No, it'd be 20,000, right? 40,000, 4,000, something like that. So I can just keep making more energy by putting heavier things in front of the spring, more momentum. Sorry, I can't separate momentum, mass, and velocity. The difference between a cannonball and a tennis ball, I can't think of that difference as anything other than energy. I can't think of momentum as anything other than energy. It's just not possible. And so how light can I go? I mean, I go, 0.01 pounds, and I only get a feeble 2 momentums. Doesn't make much sense to me. But we don't have these experiments again. So nobody's done the 3, 4, 5, 6, 7 experiments. Nobody's done the experiments to show us just how you can make more and more momentum out of the same force by simply increasing the weight of an object on a spring. Now I would argue that obviously it depends on the spring and how it's making contact with the object and how much jitter there is, and the whole quick release thing becomes incredibly important. And so there's lots of things in here that are factors that could have been creating this aberration. This could be an aberration caused by imperfections. Now, the truth is, when physicist Michael did the experiment, he did it with these cars you buy. And the fact is, they do have cheap, crap little plastic springy thing and a little plastic spring holder, and you whack it with a stick, and it's all kind of not very brilliant, frankly. So, the Professor Lewin thing is really a little bit silly, where he burns a string with a torch. But I mean, yes, the idea of a consistently length string and you just cut it, it does seem like it would be a much better launching device or system of releasing the energy. Better quick release in a true sense, not just a mechanical release, but an actual quick release. And these are all important subjects, really. I mean, in all this testing physics videos he's done and all the rest of it, he should talk about the fact that there really is a big difference. Mechanical release isn't always quick. It isn't always clean. It isn't always better than your, dull and less articulate fingers. And that the science of a quick release is an actual science. You have to figure out, how quickly does it go from being, forced into a position, and how quickly are you actually releasing the force? It's a real subject. So, Enough of that, I guess. Another relatively simple, it's just a simple way of doing this kinetic energy momentum versus kind of experiment. It's just a simple electric motor, okay, that spins, okay. And you just say, we'll put a little bit of a load on it to start with, a disc or something. It's got to spin the disc. And the fact is what's the truth? What does physicist Michael say? Does it take, if I put 1 watt of energy in, I get a spin rotation of 1 revolution a second. If I put 2 watts in, okay, will I get 2 rotations per second? I say yes, that's how it'll work. That the losses to the motor will be the same in both cases, so it doesn't really matter. But whatever you put in as watts, okay, you can expect to get out as rotational speed, all things remaining equal. And so is that true or isn't it? Now Brozo says it isn't true. That has nothing to do with watts. He's saying it takes 4 times the watts to make the motor spin twice as fast. So the other experiment you can do is to take the motor and put a stick on it, and now you can do your angular momentum experiment. So you can, or spin a disc, it doesn't really matter. And then now just move weights. Okay, so first you start with a 2 mass weights here, and then you do the experiment again with the 1 mass weights out here. All right, and the argument is it's going to, if you're putting the same energy in, same watts, okay, and my argument would be that they're going to spin at the same speed, that this and this together, all right, will equal this and this together. These two quantities will be the same thing as far as the motor is considering it as work, moving this mass and this mass twice the speed, which it'll have to be, so that can't be disputed, that they're going to move at twice the speed. The velocity of their rotation will be at twice the distance they're covering. They're going to move twice the distance in the same time, so they're going to have twice the velocity and half the mass. So half the mass, 2x the velocity. And that's going to be exactly equal to, okay, the full mass at 1 velocity. These two things are equal, and the motor will prove they're equal. Do we have that experiment? No. Conventional physics care? No. So we can only argue about it, all right, and wait for somebody to do the experiment to prove the point. And again, physicist Michael, I think he tends to say yes, but then he says no. So in the last video, I think I talked to him about angular rotation, and I said, basically described this circumstance of putting the weight, half the weight, twice the distance, and he said they wouldn't rotate at the same speed. Now, he's saying by rotation, I don't know, maybe he's using radians or something. There's some catch to what he's saying, but the point is will this spin the same speed? I said will roll the same speed down a hill, and of course it will. I put the weights out here, or I put the weights in here. If I put those two things on a wheel, so if I just take a bicycle wheel and put the light weights out here, and then I have another, I do it again, and I have the heavy weights in here, those two wheels will roll exactly the same speed down an incline. There's not going to be any difference. Their momentum is going to be exactly the same. The energy they store will be exactly the same. Can anyone argue that reasonably? I don't think they can. I haven't seen the reasonable argument against it. I appear to have covered everything I wanted to cover. So I'm suggesting that maybe somebody else, right, some person of not any horse in this race, so to speak, could possibly use their channel, like their YouTube channel, and just put up a fake video, just so there's a comment section, And we could use that comment section to post notices of videos and comments that other people make, and put those comments in that section so they can be scrutinized, so we can all see what the argument is actually being argued. So if my video says something and somebody says, I didn't say that, that's not my position, then they could place that comment in there explaining that that's not their position. Or they could put a reference to a reasonable, okay, let's just make this standard some sort of reasonableness, reasonably not slanderous content, and just say, okay, we keep this out of people's private lives, we keep all this superfluous crap out of the conversation, and try to argue just the physics. Because yes, it's not going to work this way. Okay, we do need some place to make it clear that these are opposing sides, and they have their own agendas and all this other crap, and frankly I don't trust their moderation, my enemies, okay, to do anything, okay, credible or with any kind of integrity. So there has to be some place where they're not allowed to cross all these lines, frankly. So it'd just be a suggestion, so somebody could do that. I will attempt to participate appropriately and just cite the fact that I do have videos on the Debate Physics channel. I'd like those videos refuted, if possible, by somebody who can do it in some sort of adult, mature manner. And, but so far, no takers. And this video, I would like what I've stated in this video, I'd like it to be explained how I'm talking nonsense, or I'm asking silly questions, or I'm posing that, yes, we really need these experiments. How any of those comments I'm making are irrational, or stupid, or silly, or nonsensical, or inappropriate, or foolish, or any of the other crap they want to call it. I'd like an explanation of why these aren't questions that need to be answered with something credible, with credible answers. Okay. Yeah, so that's enough. Yeah, half hour. It's okay. Alright, it's a little longer than I wanted, but it's good enough. So, till the next time, and such and so forth. This has been a debatephysics.com or draftphysics.com video presentation. Alright, I'm back. Yeah, I want to do a revision to the video. Sorry, a little hot. Here. Anyway, so talking about thinking about it. So I've had an hour or two to think about it, so I'm just going to put this extra on the video and then re-upload it instead of trying to edit out, blah, blah, blah. So the idea of rolling it down a ramp, this idea of something with the mass out here, an L extra mass, so these are, say, 5s, and then you have another one rolling with 10s here, half the distance from the center, and 5s further out. Well, the fact is it still weighs more. Okay, so gravity is what's creating the force that's permitting it to roll, and there's going to be obviously more friction for the heavier thing than the lighter thing. This is physically lighter. So the argument is that if you spun it, okay, you might run into some of the same issues in the sense that there's gravity on the bearing, and the wheel does in fact weigh more. So I think it'd be very minimal, though, just in the spinning idea. So I think the same energy will spin them, but rolling, it might be enough of a difference to notice. So this might have something to do with oscillating levers with the weight in different positions, because technically this is heavier, and it's just going to, as a fact, with the 10s here and the 5s here, and the fact is it's going to lose its energy quicker because it's heavier. So So yeah, so how much difference it makes just tells the story's told by how heavy the wheel is versus how heavy the extra weights are. So if you have a very light wheel and these weights, then it will matter because most of the weight will be the weights and rather than the wheel, and so it's going to be a big difference in the amount of friction because there's a big difference in the amount of weight, total weight. So I was thinking about gyroscopes because it's the same idea. So it'd be nice if, like I said, physics had already done these experiments so I wouldn't have to talk about it because we'd already know the answer. So if you have it in this position, the gyroscope, versus this position, versus, maybe upside down, is it more work on the bearing in this position or this position? So it's sort of interesting to think about. And then you sort of know that once in this position, you really can't feel it. So you know that the torque you're feeling, it does feel like it does, you feel the weight. That the bearing must be doing something because you're feeling it through the bearing into whatever you're supporting it with. Where in this position, you feel it less. If you try to move it, then you'll feel it. So that would be the other test, is how much longer does it spin if you don't move it versus moving it. So if you just moved it back and forth, how much quicker does it stop rotating? And that would be an interesting question to have the answer to. Because it's funny that none of that has been done. Because I would certainly argue that every time you move it, you feel the torque at pushback, and the pushback is stealing energy from the rotation. So, so it's a real significant amount of energy, even though it doesn't feel like it much. The bearings are always consuming something, and it's some percentage difference depending on how much of a weight difference there is. So anyway, just to make that clarification, I would be wrong to say these would necessarily end up with they have to end up with with the same speed, and the only question is how long it takes for them to acquire it. So I guess you could argue that the heavier one will take longer to acquire it because it's losing more energy to gravity and friction, losing more of it's gaining more from gravity, but it's losing more. So yes, they still might roll the same. I mean, it's gaining more from gravity because it's heavier, more force, but it's also losing more force because it's heavier to the ground. So whether those two cancel out is the one I'm unsure of. So I should just say I'm not quite sure of that one. And then rolling distance, you have to say the heavier one has to lose the energy faster. So if you just roll them, then the heavier one will run out of energy quicker, even though they start with the same energy. So they're spinning at exactly the same rate. Theoretically, they would have the same momentum, but the heavy one will lose the momentum quicker because it's heavier. Yeah, and but if you just spun them and then tested them by having a bar on them and have the bar hit something, they'll hit with the same momentum, the same energy they'll hit with the same energy, even though the masses are in different locations, because then it will, even though they have a different mass, because frankly it's where the mass is will matter then, because you're going to take all the energy or a big piece of the energy. I would argue you have to take the same amount of energy. Well, anyway, there's a lot of subtleties to the question, so I just wanted to say, subject to further thought. My opinion may slightly change. It won't change big, it'll change a little. So just thought I'd better throw that in as a qualification on the subject of angular momentum. Still argue the momentum will be the same. The angular momentum will be the same, but the total momentum of the object will also be the same, but it won't behave the same depending on what circumstance you put in it, because there is an absolute difference between the two wheels that's detectable. I guess that's the point to make. There is a detectable difference. And in some circumstance, there'll be no difference. And in some circumstances, you'll detect the difference. I guess that's a good enough way to qualify the statement.